Hi, welcome to another video on my Raspberry Pi with fischertechnik pulse width modulation motors and some electronics. And last time I figured out that although I'm using pulse width modulation with the correct value, probably the resistance is not quite right. To that end, to solve it, I already added a resistor here, but I need to add more resistors in order to get the frequency correct. So what I want to do is, with these resistors here and this one here, to double the resistance, and that means that I have to add resistors in series, just like I did here. So that is what I'm going to do right now. And let me grab this tool. And put this at let's say here. Grab the next resistor and put this one right here, this one right here. They're the same value, but in series they add up. So with the values of the transistors around the op amp, that is going to be a challenge. So what I want to do right here, and let me get some better light on it, I have to put one in right here somewhere, but that's going to be pretty tough because of the number of resistors here. So first thing to do is relocate, for example, this one, and that is going to be, for example, here. Then this one will be here. But what I can also do, in order to remember that this one goes here, put this one right here, and the new one in series here and here. And that may be the solution for the other ones as well. So this one, let me say right here. There's a slight relocation, and the other one goes here. So this one goes, and now I should make no mistake at all, and I already made one here, because this one should be here, because this is a connecting lane. So this one has to be here, and then this one can go here. So now these two are already in series, and now this one has to be put in series as well, which is not that hard. But considering that these two lanes have been put in series already, and I hope you can see that because of these resistors, that is going to be a challenge, but I'll let it be for now. Start the software and start measuring if I actually obtain the right frequencies now. So first things first, I will switch on the motors by that is one thing. See if this motor works. It's not working at all. Anyway, now it's time to measure some frequencies. I already put the multimeter on frequency. So one probe up on the mass, one probe here. What do I measure? Uh, 500 Hertz, which is too high. What do I measure here? .500 Hertz is too high. So then it is time to measure, for instance, on the motor. Which is now almost 400 Hertz, which is still too high because maximum is 120. So the question is, what do I have here? Way too high. What do I have right here? This is 400 Hertz, almost 500, way too high. So this actually shows that just adding resistors is not really a solution. On the other hand, and you make always a mistake, well, often. Actually now the pulse width modulation is active. This is 700 Hertz. This is 11 kilohertz, way too high. Way too high as well. So we keep measuring, and this is with the pulse width value at 1024. So let's check this at 10, for instance. What does that give? Again, against mass, right here, 6 kilohertz, going through the roof, right here. So something is odd, and let me just that is too much. Alright. Much lower speed. What does it do? At a value of, and I put it again, 1024 pulse width value. What do I get? Again 500 Hertz. And at the motor, at this one anyway, as you can see, it is close to 300 Hertz. But not close to 220 Hertz, and that should be. So just on the other hand, I haven't added a resistor here, and this circuit is after the op amp, so let's add a resistor there as well. And adding a resistor right here can be done, but it's going to be very tight unless I move all these points there. And I think I'm just going to put this connection right here. I have to keep in mind how exactly that is going to work out. So this wire will be here, then one wire up there. Right here, and then this resistor is going between here and here. Right here, right there. So the point now is, of course, that now none of the resistors should make physical contact, but as I look at it now, they really don't, and everything is in series. So let's try once again. Okay. Well, this motor for some reason still doesn't want to cooperate. I have no clue why, but this motor fortunately does. And let's just measure between, again, this point of mass and I want you to show the value. So this is going to be a bit tricky. This is again way too high. So that actually means they're just indeed adding resistors in series to lower the value isn't helping, unless the value is still too high. So I can measure that, of course, putting the, as you can see, the multimeter to ohms resistor, and then checking this value, and to get the positive value, although that shouldn't be necessary. And that is odd. There's another possibility to check if anything is connected anyway. Okay, this means that between this point and this point there's actually not even a connection. Here's a very faint sound of connection. And that's even odder, because I don't even hear a sound here. So what is going on? Are the connections correct or not? I can check with this wire. This works. This works. And this should work, but doesn't. So there's something wrong in the wiring. Very interesting. I need to check the circuit. Okay, so time to measure some connections. Of course, a resistor is connected, but since it is measuring, let me show that up close. Since I'm measuring the connection in the resistor scale, any resistor will give a value and not a beep. So to demonstrate, this is giving a beep and this is giving a value, and actually this is giving a value of 187 ohms, and from here to here that should be it doesn't measure anything. This is, and this does, and it says okay, between these points there is a connection, there's a resistance, and here there's no resistance. And remarkably, why doesn't this give a resistance value? This once again does. This is somehow off the scale, which I don't really get. Let me put this in a different scale. Kilo ohms shouldn't be. Nope, as expected. Ah, this is indeed double the value. which is over 200 ohms. This is 344 ohms. That is the reason I didn't measure anything. And in the video, in the previous video, I showed that the resistance should be around 300 ohms. So actually this is very close to what it should be. Actually it is correct, and let me measure this. So between this point and this point, that is measuring 180. Am I measuring correct? Yes. This is not up to it, but it is touching other resistors, so in this case still not up to it. That is remarkable. And this one is connected through this one, so I have to measure here, which is also not really up to it. So that is quite remarkable. And if I take this one and this one, that is up to it, that is correct. So why aren't these up to it? Yeah, this is not 200 ohms, so these resistors are not up to it, and that is very strange. I need to replace those resistors. To show the weirdness of the situation a bit, I'm using this crocodile beak or clamp, put two of exactly the same resistors together and measure them the same way as I've done so far. So here and here, there you go, about 344 ohms. So when I measure the exact same resistance on this point, bending them back to avoid physical contact, which is a bit hard, but here and here it should be the exact same amount, and they're not. So if I do it here, it shows the right amount. If I do it right here, and I shouldn't be in my own light, it shows the exact same amount. And when I do it here, for some reason, yeah, now it does, on and off. So this is the amount I want to have. That means that in this breadboard somehow the connection is a bit flaky, unfortunately. which also explains why I cannot get a good value. For instance, when I'm doing it right here again, this is correct, entirely correct. Here I have the same resistors as well, value, and I don't care right now for the minus or the plus, but the value is more or less correct. So here is the culprit. Let me once again take these two, because these two should, and they give the correct amount. Mind the motor and the propeller. Then the ones in between, no physical contact with the others. And what do they show? I have to be careful. And they show just 165. So this is giving me a problem. How are they interconnected? Are they really on the same lane? These two are on the same lane. These two are on the same lane. And are these two on the same lane? Yes, most definitely. So why is right now one giving a bad connection, and that whole connection influences the rest? I'm not quite sure. But again, referring to the schematics on that website, the value should be 300, and with a different resistor value, total resistor value, the frequency of the pulse width modulation can of course be totally different. And with that, I think I end this episode. Next time I will try to improve everything. For now, let's get back to measuring the frequencies once again. For the last time. It's still at the maximum pulse width, so the frequency should be quite low. But unfortunately, here it is wrong. Here it is wrong. Zero value right now. With the motors not running. So for the last time, and the motors even don't run. So enough to check next time. Stay tuned. Thanks for watching, and to be continued for sure. And if you like these videos, if you haven't already subscribed, please do so. Bye bye.